Okay, so why are we talking about big power today? We're talking about big power because the rapid increase in power demand is staggering. I was at a recent roundtable event where Paul Miller, our president at Collicut, made the incredible comment that here in Alberta, which is where I'm based, Alberta, Canada, we have approximately 12 gigawatts of interconnected load. 12 gigawatts, it's taken 80 years to build 12 gigawatts of load. And here in Alberta, on the interconnection queue, there is 20 gigawatts of data center applications. So what has taken 80 years to build? We are talking about grid demand that's twice that being needed in the next few years. Now, realistically, not all of those projects are going to be developed, but nonetheless, we are seeing rapid deployment of rapid increase in demand in areas where previously there had been flat, if not declining, power generation requirements. This is straining the grid. And so today we are going to talk about how the MTU Rolls-Royce 20V4000 lineup can be an economically feasible option for behind the meter generation. And I'll get into that phrase. You're going to hear it a lot today, is behind the meter generation. It could be very reliable and in large volumes, equally reliable to other technologies, and in some areas of the continent, even more reliable than some of the grid supply. Ramp rate resilience. This is a phrase that we've developed as part of this presentation, but the engines in large volumes can sustain consistent load volatility that we're seeing in these types of data centers and with less power conditioning requirements. Availability. Engines have the unique capability of being built and deployed in low lead times, especially when you consider the modularity of the application. Space efficient. Many people talk about how if you're going to build a power plant, you build one large unit. Makes sense. It's very conventional. But we're going to show in this presentation how similar amounts of power generation can be deployed in similar real estate. Minimal derating. Engines have the unique capacity to be less impacted by temperature and elevation and sometimes fuel quality with minimal derates. Engines are designed, especially the MTU Rolls-Royce solution is designed for high start-stop frequencies and as much as greater than 500 start-stops per year without really any degradation to engine life and minimal OpEx impacts. And one of the best things, especially when we talk about data centers, is engine generators have a closed-loop heating rejection system, which requires minimal water usage. Okay, so let's get into the agenda for today. I'm going to do a quick little intro to Collicut. I'm going to do a quick overview of the power demand that we've already talked about. Then we're going to do a technology comparison that Gordon referred to. We're going to introduce the Rolls-Royce 20V4000, and we're going to talk at a very high level to some of the ways that we can package large amounts of power. And then finally, Q&A.